تفضل.
Okay, assalamu alaikum. Hope everyone's having a wonderful day filled with knowledge. Today, me, Hanan Bukhari, I'm a third-year medical student, and Reem Al-Gablan will discuss the ECG basics for all of you, hopefully giving you some tips and tricks and some mnemonics for you to remember some of the things which you need to memorize because it's basically all memorization. So without further ado, let's begin. Next. Okay, so today's objectives are going to be the definition of an ECG and its clinical importance, and the basic anatomy and physiology of the conduction system. And then we will discuss the leads placement, and then we'll talk about the ECG paper and the complex and the rate and the rhythm. Moving on, this is me. I'm going to talk about the first three objectives, okay? And I might ask you some questions, so you can write your answer in the chat box or you can raise your hand so we can unmute you, okay? First of all, we will start with the ECG definition. To know the definition, we need to first of all expand ECG. What does it stand for? It stands for electrocardiogram. Does anyone know what electro means? I mean, it's pretty straightforward, so hopefully everyone knows. What does it mean? Anyone know what electro stands for? Exactly. I read some in the chat box say electricity. Perfect. Yeah, electricity. So electricity or electrical activity. And then cardio. Anyone know what cardio stands for? Heart. I read some hearts in the chat. Thank you guys. Yes, it's the heart. And then gram stands for a record. So the definition, it is nothing more than a record, we talked about that, of the heart's electrical activity. It comes from the name itself. But I'm going to add to the definition that it's read on the ECG paper right here in pink, and then by the ECG machine. And we need leads and electrodes for that. And we'll discuss the electrodes by the end of the talk. Let's complete with the clinical importance. Next slide, please. Okay, so clinically, why is it important? It's remarkably important with remarkable clinical power because of two different reasons. Number one, it's very easy to master. Why is it easy to master? Because if I tell you something, like if I tell you on an ECG, this part going up means depolarization, you will remember this. You will remember that this picture means depolarization of the heart. And I'll explain what depolarization is in a minute if you're confused. You'll know what it means, don't worry. So I told you what it means and you memorized it. So it's easy to master. Everyone can read this part. And the second thing is that it has extraordinary range of situations that can be provided. It provides helpful and critical information such as myocardial infarctions or arrhythmias or atrial fibrillation or anything like that. And we'll get to know these in a bit. Let's move on to the next slide. We'll talk about the anatomy and the physiology of the heart. Okay, next slide. Okay, before I start with anything, there's this rule that I really love to do so that I know which side of the heart is the right side and which side is the left side. Okay, first of all, let's pretend this is you. I'm sorry, guys, my drawing sucks, but I'm going to do it just for the sake of understanding. This is your right hand, okay? So what you do, you will shake hands with the heart. Shake your hand with the heart. So whenever you shake hands or like تسلم على أي أحد, يدك, it's going to cross to the right side, right? You cross your hand to the other side. So when you cross it, you سلمت على heart. So this is the right ventricle. Just shake hands with the heart and you'll find the right side. Because the left side of the screen is the right side of the heart. Don't get confused, okay? So now that we've covered this part, let's look at the next part. Then the next part, I'm going to give you this really nice thing that I learned in high school from an amazing teacher, and I still remember it till this day. She told me that an artery, A stands for, just remember the A, away from the heart. So the artery takes the blood away from the heart. That means the vein is going to do the total opposite. What will the vein do? Go into the heart, right? So this is an easy thing to remember. You will always remember this. So right ventricle, we discussed this just now. The right ventricle, oh my God, you guys need to notice this part as well. Look at the cardiac muscles on the right side of the heart. It's very thin compared to the left side. Look at the left side. Look how large and thick that is. Why do you think that is? Because the right side will push the heart to the pulmonary part, which is the lungs. Lungs stands for pulmonary. So if it's going to push it to the pulmonary, we're going to use the pulmonary artery. And again, A stands artery, away from the heart. It's taking the blood away from the heart. And then if it goes to the lungs, what will happen next? The pulmonary vein will bring it back into the heart through the atrium. And why does the blood go back into the atrium? Look, the ventricles have muscles pushing the blood away, but atrium it doesn't really have that much of muscles. So it just takes the blood. It doesn't really do much. Okay. The atrium will receive the blood from the pulmonary vein and then push the blood into the left ventricle through the mitral valve, also known as the bicuspid valve. What does bi mean? Does anyone know what bi means? Do I have any answers? 2. Yes, I read on the chat there. It means 2. Perfect. Bi means 2. So it has 2 valves. 1, 2. If you look at it from the bottom, it's 2. Okay. And then it'll move from the left ventricle. Remember, the left ventricle is a thick muscle, which means it'll push to the whole body. And then again, we're looking at the aorta. Away from the heart. Again, guys, this is away from the heart. All the way to the rest of the body because the left ventricle is strong. It pushes it to the rest of the body. Then we're almost done. Now that the blood is going to the rest of the body, how does it come back? Through a vein, the inferior vena cava and the superior vena cava, going into the right atrium. Again, the atrium doesn't have muscles, so it just receives the blood. And then it'll push the blood into the right ventricle through a tricuspid valve. And tricuspid valve, look guys, this one is really nice to remember this part. Tri means 3, okay? And the valve, if you look at it inferiorly from the bottom, you will see 3 valves looking like this. And this looks like a Mercedes sign. And the Mercedes sign, but it's the opposite of a Mercedes sign because the Mercedes sign is flipped, right? And a good way to remember this is that you can make a mnemonic and say that you could try to buy a Mercedes, but we don't have the money for that. So anyways, this is it for the heart anatomy. We'll move into the deeper structures of the heart in the next slide. Now, the deeper structures of the heart, this is pretty simple to remember. The sinoatrial node is the pacemaker of the heart. And when we say pacemaker, it means that it's going to control the rhythm of the heart. And how you can remember that it's on the right atrium, the right side of the heart, is because your right hand is your dominant hand. So you write with your right hand, you draw with your right hand, you eat with your right hand, you do everything with your right hand. So the heart as well has the sinoatrial node, the pacemaker, on the right side. Makes sense, right? And then the SA node, what it does is that it sends electrical signals to the left atrium as well as the right atrium, passing it into the atrioventricular node. From its name, atrio from atrium and ventricular from ventricular. And I don't know if you guys remember, we just talked about the tricuspid valve. The tricuspid valve has another name known as atrioventricular valve. So that's why we called the AV node atrioventricular node, because it's above the AV valve, okay? What it does, the job of the AV node is that it delays the signal of the SA node going onto the ventricles. And why does it need to delay the signal? Because it waits for the blood to all pour out of the atrium into the ventricles. It's going to wait until all the blood has poured into the ventricles and then send the signal. Okay, so it just delays. And then the atrioventricular node will divide into the bundle of His. The bundle of His divides into 2, the left bundle branch and the right bundle branch. These branches will go down this way. This is important to notice, guys. This is a really important part. I'm going to ask you a question in a minute. And then it goes up. And then Purkinje fibers come out so that they can send more specific signals. But why does the signal go down and then goes up? This is the apex of the heart. Does anyone know why we want to start the contraction from the bottom going up and not from the top going down? Can anyone guess? It's a pretty hard question, but it's fine. Just give me any random guess. Okay. Oh my God, you guys actually know this. You know the answer. Perfect. You said to push the blood out. That's amazing. Good job, guys. Okay, so it's because, let me just explain why. Let's say this part contracts, okay? If this part contracts, what happens to the blood? It'll go down and then it'll accumulate at the bottom. We don't want that. Why would we want it to accumulate at the bottom? You guys remember in the anatomy, the pulmonary artery was at the top. So we want it to contract from the bottom to the top to get the blood going upwards into the pulmonary artery. Okay, that's it with the anatomy. There's so much anatomy. I bored you guys with the anatomy. Let's move on to the physiology. Hopefully you guys love physiology. Here we go. So the cell itself, it's very important to remember that the resting charge of a cell is that it's electrically polarized. And I'm going to give you a mnemonic to remember this. It's a weird mnemonic, but anyways, do you guys know what a pole is? Does anyone know what a pole is? Any guesses in the chat? It's fine. I'll draw it. Look. No need. It's just the pole. You know, firefighters, do you know how sometimes they go down a pole and then they go and, like, you know, what's it called? If there's fire, they just like extinguish it. They go down this pole. Fun. But the point is that a negative sign kind of looks like a pole but tilted. So you can remember it like that. So it's electrically polarized. That means the inside of a cell is negatively charged. Okay. So you have to remember that. But why is it negatively charged? It's not proper negatively charged. It's negatively charged in comparison to the outside. So the outside has a lot of sodium channels, sodium ions, I'm so sorry. Sodium ions and a lot of calcium ions. A lot of these too. The inside of the cell has a lot of potassium ions, but that's it. So the outside is more positive than the inside, and that's why we call it negative. But how do we keep it at this state? We need membrane pumps. Look at this guy. This guy we'll name him energy. He's basically the energy. Okay, don't worry, guys. We don't have a proper dude in our heart giving us energy. No, it's just energy. This is just for you to remember. It's like a visual thing. And then the pump, it's not a proper pump that pumps air into anything. This pump is just the membrane pumps the channels, the ion channels that will keep the cell at its resting state, whether negative or change it or depolarize it. What do I mean by depolarization? Let's look at that in the next slide together. Okay, cellular electrophysiology. What happens? What did we just say? The resting cell is, what was the resting cell of the heart? Usually, remember the pole? Does anyone remember? What's the charge for the resting cell? We just discussed it. Negative. I read one negative. Good job. Okay, so the resting one is negative. So what happened here? Depolarization happens. What's depolarization? It changed. It's not polarized anymore. It's positive. It changed to positive charge. And how that happens, I'll explain that in a minute, but just understand this concept, okay? And then what happens is propagation. It moves from one cell to the next. It propagates until the whole heart is depolarized, which is like from the very first slide. You remember what I said when you read something and it could be depolarization of the heart? Now you understand what I'm talking about, right? Hopefully you do. Okay, and then after depolarization, repolarization occurs. Repolarization meaning like regenerating something, remaking something happen. And so we are going back to the resting polarity. If you guys remember it, it was negative, it was a pole. And then it just goes back until it becomes repolarized. Let's look in the next slide what I'm talking about, but as a form of a graph. Guys, when I was younger, I used to not younger, like it was just last year, but anyways, I used to get so confused. What is the difference between this graph and then the ECG graph? Why are there two graphs? It's so annoying. But I made it simple for you guys over here. This is the only thing you need to remember. This graph, the action potential graph, you only need one cell. They are talking about one specific cell. You remember the cell that we're talking about with the dude, you know, giving energy? It was one cell that was negatively charged. But over here, they're talking about this one cell having the depolarization and the repolarization as well. And then they drew it as a graph. When it comes to an ECG, I put a picture on the side with a full heart so that you remember that the ECG reading is the whole heart, not just one cell. So hopefully you guys can differentiate between these two graphs, okay? The action potential graph, you should remember that the x-axis is time, and then the y-axis would be the amplitude or the voltage that we're going to be needing to talk about. Over here, this part, this is just the atrium or the ventricular action potential. It's not that important, but I'll explain it really quickly. So if the cell is negative, and then let's say we influx, oh yeah, you have to know this, guys. Influx means into the cell, going into the cell, and then efflux from the E, exit, okay? So you're exiting something outside of the cell. So let's say this negatively charged cell, sodium goes in. If there's efflux of sodium, what happens? What happens to the charge? Does it stay negative, or what happens to the charge, guys? It becomes, someone says positive, and depolarization, exactly, thank you guys, yes. So it becomes more positive or depolarizes. So it becomes more positive going up, depolarization. And then this part, you can see it's kind of like a plateau. And so why is it a plateau? Because in this state, what's going on is that some calcium is going into the cell, but then at the same time, potassium he just wants to be a rebel. He's like, I'm going to leave. So what happened is that there is an equal going in and out of the charge. So it kind of stays plateaued. And then after that, the calcium closes, and then the potassium opens, and potassium is effluxed, and there's repolarization. If you guys remember, repolarization was going back to the resting state, going back to being negative. Okay, this is not that important. Let's move on to the SA node action potential. This is the one that's more important, and I want you guys to focus on that one. For this one, the action potential, okay, sorry, this is the closest thing I found. On the side, it's not proper what the channels do, but I'll give you the accurate one. This is just like an outline, but I'm going to give you the proper thing. We have the sodium going into the cell. This sodium channel is known as the funny channel. Okay, the funny channels will have sodium going into the cell, depolarizing it or making it more positive. Potassium is closed. Okay, I'm sorry, I don't know why they put potassium here. Potassium is closed. So it'll move from -60 and slowly, this is the time, so it's moving slowly and depolarizing slowly, and then it reaches a point where it closes. It'll close. Okay, this one's closed. I'm sorry, I don't know why it's there. Potassium is also closed, and calcium decides, I want to go in. Calcium, this channel is known as the T-type calcium channel. This T-type calcium channel, T stands for transient. I don't know if anyone knows what transient means. Does anyone want to give me a guess of what transient means? Just a quick guess. It's okay if you get it wrong. We're all here to learn. Transient, the meaning of transient. No, not shafaf. Transient kind of means like I mean, you could kind of say temporary. Someone said temporary, perfect. Or stayed for a time. Okay, perfect. So it just stays for a little bit. It's transient. It's going to open for a little while. It's just going to trick you. It'll open for a little while until it reaches this action potential. And then I'm going to add a step here, guys. And this is where the calcium, a new calcium channel opens. This channel wants to close, and we want to open a new one known as the L-type. This L-type calcium channel, the L stands for long. So what happens here is that it opens for a good time, and then it whoosh, you know, a really quick depolarization happens. Like, whoo, it's really quickly. You see the time? It just happened in a really short time. And it reaches a point where it goes to the very last step. This should be 4. I'm so sorry. So the potassium will go out, no sodium, just potassium goes out. And when potassium leaves, when a lot of potassium leaves, repolarization all the way until the -60. The same process will repeat itself. Sodium opens, then calcium opens the T-type, and then the calcium, the long type, and then potassium. What am I saying? Hanan, what are you saying? Everyone's asking, what is this? Let me show you in a picture in the next slide so you can understand in a better way. Okay, so this is what I'm talking about, okay? It's a graph, it's an action potential graph for one cell, for the sinoatrial node in specifically. The first step was the funny sodium channels opened. The second step, the transient calcium type channels opened. Then the third step, where the L-type channels opened. And finally, the potassium channels did an efflux. They left the cell, causing repolarization. And that's it for this part. I mean, maybe you guys are a little tired, but I'm so sorry. The next part is a little difficult, so it's going to need you guys to concentrate just a little more. We're going to talk about the leads, and it needs a lot of the remembering, it needs you guys to remember, I need you guys to remember the last part that I said. Okay? So for the leads, what I'm going to talk about right now, I'm going to start with something that we took in physics a while back. Hopefully you guys remember physics. This is a circuit. And then, do you guys remember what this stands for? The X, you know, when you draw a circle with an X? I don't know if you guys remember, but can you give me a guess? The circle with an X, the mystery circle. What does it stand for in physics? You can write down in the chat box, or if anyone wants to raise their hand, it's fine. No one knows? It's fine. It's a hard question anyways, I'm sorry. No, not blockage. This one stands for a light bulb or a fuse. It could be fuse, but like I like to use it as a light bulb. The light bulb is basically in this circuit, okay? This is the negative charge, this is the positive charge. And we all remember that the circuit has a current, and this current moves from the negative to the positive. And if we have a current, what happens to the light bulb? Can anyone guess? This is an easy question, come on. It turns on, yes, it'll light up. So now we have light, okay? Same thing with the heart, okay? The waves on an ECG, they reflect electrical activity of the myocardial cells. And again, look, I've emphasized the S here so that you know that the ECG right now we're talking about, this graph, is the whole heart, okay? So what happens is that this ECG machine will act as a voltmeter. Let's say if we replace if we replace the light with a voltmeter, okay, what happens is that the voltmeter reads the current, how much current we have. So this ECG will read how much electricity, the electrical activity that we have and draw it and tell us repolarization, depolarization, and all of that. Okay, guys. Now, the heart is a three-dimensional organ. So if we only place a couple of electrodes, that will not do the trick. These are electrodes, okay? The ones that you put on the hands or the chest, we'll discuss them in more detail in a bit, but they're not enough to use just a few. You need 12 leads. Now you're gonna ask me, Hanan, why do we need 12 leads? That's too much. I'll tell you now. And you guys are gonna know by yourselves in the next part. I have this little game for you guys. It's not a game, it's just a little question. It's kind of like a game. So guys, guess with me right now. Next slide. So this little game, we have an elephant. This elephant is pretty huge. So if we're going to stand in front of it, we're going to see like a little part of it, right? There are three different views of this elephant right now. There's this guy in the tuxedo. What is he seeing? Can anyone guess what he's seeing? What is he looking at? The trunk. Someone said the trunk. Exactly. This is the trunk. Oh God, what did I do? I'm so sorry, guys. Okay. So this is the trunk. He's looking at the trunk. What about the guy in the red shirt? What is he looking at? Quick guess. The body. Yes, we're looking at the body on this side and the legs. You could say we could say that we're looking at the legs. And then the female, what is she looking at? She's looking at the tail. Yeah, perfect. Someone said tail or the legs from the back. This question is going to answer all of our questions. One question answers every question. Look, I'm going to ask you guys, and I want you all to answer. Everyone should answer this right. If you want the best description of this elephant, so we want to ask someone to give us the best description so we can draw this elephant. Who will you ask so that you can get the best description and draw the perfect elephant? Who do you ask? Someone says tuxedo man. And then someone says all three answers, red shirt, all of them. It should be all of them, guys. It has to be if you ask all of them, then you will put the pictures together and you get a whole elephant. And it's the same thing with the heart. We said it's a three-dimensional organ. It needs many leads in many different angles and orientation. We'll look at the angles in specific detail to know where we're looking at the heart and then draw the ECG. It's very specific. Okay, next slide. The first type of lead is known as the bipolar limb leads. Again, I'm going to ask you guys, what does bi mean? You guys have already answered this, so it should be easy. 2, perfect. And then polar, we're talking about bipolar. So 2 of the polarities, both of them, the positive and the negative poles. Okay, does anyone know what are the limbs? What are your limbs? Arms and legs, perfect. Someone said arms and legs, that's it. You're right, arms and legs. So that means we're gonna add those leads or electrodes in the arms and legs. Okay, I'm gonna draw, okay, excuse my drawings. I don't know how to draw, but I'm gonna draw it just for the sake of memorizing, because I'm gonna give you a really nice way to remember this. I've remembered these since last year until this year by this way. You guys will remember it as well, hopefully, okay? So this is a lead on the right arm, okay? And then this is a lead. I'm just so funny. Anyways, this is the left arm. And then the circle is the lead. And then the left leg, we need the left leg as well. And then we have a lead. And when it comes to leads, we always draw a triangle. But before we do the triangle, I'm going to ask you guys a question. Now, if we have, they're going to be positive and negative. Remember how we said 2 poles, bipolar. So we're going to use positive and negative charge with the leads. We're going to make them positive and negative. What will that do to the human body if there are like positive charges, negative charges? Can you give me guesses? Any guesses in the chat box? It's fine. It's a hard question. So there is neutralize. Okay, that's what you need to do. That's basically what you need to do, okay? Because when you have positive and negative charges, this could cause excess charge going into the human, right? If there's an excess charge, this could cause problems. So what we need to do on the right foot or the right leg, we add an electrode known as the earth or grounding electrode. We earth the person or we ground it to remove any excess charge. We don't want excess charge, okay? So we're gonna, but anyways, it's not important in the leads, okay? So we'll just erase it for now. This is just for your knowledge, okay? What we need to know today with the bipolar limb leads is that, okay. Before we know this part, I'm gonna ask you a question. Is the heart placed on the right side of most people or on the left side of most people? Like, where is it located? This is the mnemonic, guys, or the trick to memorize. It's on the left. Yes, everyone's saying on the left side. Good job, guys. Yay. So it's on the left side. The heart is usually located on the left side. So if we say that it's on the left side, present on the left side, add a positive sign on the left arm, positive sign on the left leg. We'll add 2 positive signs on the left legs, okay? But then there's always an exception to every rule, okay? So there's an exception to this rule, but I'll just tell you what the rule is, okay? Positive electrodes on the left side. The right arm, there's no heart. There's no heart, we add negative. We'll add 2 negative charges. I won't tell you the exception just yet. Let's tell you the leads first. We said it's gonna look like a triangle. And remember how we said in the current, when we do a circuit, it moves from negative to positive, right? So the charge is gonna move from the negative side to the positive side, giving us lead 1. So right now, this is perfect. We have a negative, it's bipolar, positive and negative. We have a negative charge. We have a positive charge. We got lead 1, right arm to left arm. Perfect. Hopefully we all agreed on this. Okay, then we move from the right arm to the left leg, right? Because it's negative. We want to move from negative charge to a positive charge, and we have lead 2. Okay, so lead 2, perfect. We have the right arm having a negative charge because we don't have any heart on the right side. The left leg, we have a heart, so we add positive charge, lead 2. Now lead 3, number 3 is usually the one that's annoying. This is the exception. For lead 3, we said the legs will keep it positive at all times. However, the left arm will add one single exception, the negative sign, because we need 2 different pulls, positive and negative. So it'll move from the left arm to the left leg, right? From negative to positive, just like in the circuit, giving us lead 3. Amazing. We just have those 3 leads now, from the left arm to the left leg. To simplify it more, and my drawing sucks, so I'm going to go to the next slide, giving you a better picture. Sorry for the bad drawings. This is a way better picture. Ignore AVR, AVL, AVF for now. I'll tell you about them in a minute, but we'll just look at lead 1. Lead 1 moves from where to where? The right arm to the left arm. Has to be from negative, because right arm, there's no heart, so negative, perfect. Left arm, there's a heart, positive, perfect. We got it, okay. The next one, lead 2. We add a negative sign on the right side. The right side is always negative, there's no heart, okay, negative. Moving to the foot or to the leg, positive. This is lead 2. Lead 3, this is the exception. The left arm will add the single negative charge so that we can go to the positive charge and have lead 3. Why am I telling you this? Do you guys remember the elephant? Because we need to look at the heart from different angles. Let's look at these specific angles in the next slide. This one, yes. Okay, this is pure memorization, guys. But for the sake of you understanding why the angles are like this, I'm going to explain this little part. In math, when you have a circle, if you move clockwise motion, is that positive or negative? Does anyone remember? If it's a clockwise direction, is it positive or negative? Do I have any answers? Positive. Perfect. Okay, some of you said positive, some of you said, but it's positive. Going clockwise, always remember, clockwise, going like the clock. So it's positive. The clock is always going, clockwise. So it's always positive. Positive. And then anti-clockwise will obviously be the opposite, negative. So let's say we take this as our initial point, and this is 0 degrees. We'll move clockwise in this direction. If we have a right angle triangle over here, what is this angle? Yellow, this is a trick question. I'm just kidding, it's not trick. 90, someone said 90. Okay, how about this? Is it going to be positive or negative? I just explained this part. 90, but is it positive or negative? It's going clockwise. Perfect. Yes, it's positive. It's going to be a positive 90-degree angle. And then same thing, we keep going clockwise. 180, positive. Then 270, positive. Then 360, positive. Okay. Now, if we do the opposite, if I go this way, if I go anti-clockwise, what is this angle? Again, this is our right angle. Yeah, negative 90. Perfect, guys. Yay. So you guys understand. And then you move down here, negative 180, and then down, and so on. Okay, you guys get the picture. Okay, why am I telling you all these numbers? Because right now, the heart, the leads, sorry. Lead 1 is the easiest to remember, because if you guys remember, it was from the right arm to the left arm, and we said right side, no heart, negative, left has a heart, so positive. And it's just a straight line. Khalas, it's 0. It's so simple, really easy to remember. Okay, the next part is going to be lead number 2. Right arm to left leg. Right arm was always negative, no heart. Left leg positive, always. And then going down, it's positive 60. This is a number you have to memorize. Oh yeah, and for this, we were talking about the elephant, looking at the elephant from different angles. So what's the angle we're looking at? Here, let's pretend this is an eye. So your eye, or basically the electrode, is looking at the heart from here. So it's looking at it from basically almost the inferior angle, but like at an angle. So see how specific it is. It'll give you the most specific, accurate readings on an ECG, because it's looking at the heart from a 60-degree angle. Over here, it's looking at the heart from a 0-degree angle. And then the last lead, we just didn't talk about it. Just let me give you a minute, okay? It's 120, positive 120, because we're going clockwise. So this is lead 3, and the eye is going to be over here. You're looking at it from this angle, which is also from the bottom, okay? Let's move on to the next leads. I'm sorry, guys, some parts you have to memorize. But anyways, next part is the unipolar leads. The one before was bi, so we need both the poles. In this one, you only need one pole. Which one? It's okay, guys. Technical difficulties happen all the time. Okay. Technical difficulties have been solved. Unipolar leads. Unipolar means one. And when we say one, we only need one pole, the positive pole. That's all we need, okay? And then limbs, again, we all know that this is the arms and the legs. So we'll add the same place, the same leads that we used before, but we won't charge all of them. Like we won't charge two each time, we'll charge one only. So let's say on the right side, this is the right hand, and we charged it a positive charge. Okay, how are we gonna get an angle? Okay, who's the most amazing student who remembers what I said at the very beginning of the lecture? The heart, the resting polarity. What was it? If this is the heart, maybe I should draw a proper heart. Negative. Oh my God, you guys remember? Yay. So the heart, the resting potential is negative. Khlas, we have negative, we have positive. We'll have an angle. Perfect, right? And we call this an AVR. R stands for right, and then augmented voltage. Right arm positive. Augmented just means that like when we say augmented, we just mean that the machine itself is going to amplify, increase the voltage that we're going to receive from this, because we're using one lead, you know? Okay. AVL, same thing. We have a left arm with this, and then from the heart negative, we make it positive. This is an AVL. And then AVF going down, because the leg is at the bottom. The leg is going to be positive. Very simple, right? Let's look at the picture, guys, real quick. Okay, so I told you guys to ignore these, but now we're going to remember them. AVR is the red. We made it positive. And then the heart, we just said that it was negative, so we moved this way. And then for the left side, we moved that way. Okay, for the foot, we went down. Who will know the angle? You guys can actually guess this angle because it's so easy. Okay, let's draw the circle quick together. We're moving clockwise. What is this angle? Who can guess? It's so easy, guys. Positive 90. Someone said positive 90. Exactly, yeah. It's a right angle triangle. It's not triangle, sorry. It's right angle, because the heart is here and then it's going down. It's going straight down. So it's a positive 90 degrees. This one is really easy to remember, just like lead one. Lead one was 0. Can we move to the slide after this one? We're done with this one. Okay, this slide. Just like before, we had angles, so this time we'll have angles. Let's start with AVF because we already said this and we talked about it. Positive 90, very easy to remember. Okay, guys, now we're going to move into negative angles. Why? Because which is easier? For me to say this huge thing and say positive 330, or is it easier to say negative 30? Go anti-clockwise and just say negative 30. That's a lot easier, right? Right or wrong? ولا تبغوا تروحوا 330? Yeah, it's much better to do negative 30. So we'll just do the tiny angle. We'll go negative 30 for the AVL. Why? Because this is the heart is negative, and then this is the left arm going this way, from negative to positive. Remember the circuit. And then we have AVR going from the heart is negative, all the way till here. And then again, this one, going anti-clockwise, is a lot smaller than when you go this way. This one's going to be more than 180. It's going to be 100 something. I don't know how much. We don't want more than that. We just want 150, less than 180, right? So we'll take the negative 150. And then, guys, remember, we're looking at the heart from here. This is from the right side. We're looking at the heart from here. Okay? Okay, خلصنا الحين. The next slide, we're going to discuss the same thing. This is a revision because the best thing to remember, anything you need to memorize, is revise. Lead one. We'll start with the easy ones. Lead one was 0 degrees because you just go from the right arm to the left arm and it's from negative. There's no heart here. You put negative, positive. خلصنا. Lead 1. Then AVF was easy. It was 90. Going just when you say AV, it's just positive here, and then the heart is the negative one going down. Easy. خلصنا. طيب, lead 2. Lead 2 is positive 60 because we're going this way. Right arm, left leg. Then lead 3, 120. So it's easy to remember, positive 60 and negative 30. Lead 2 is positive 60 and then AVL is negative 30. You can connect them if you want. I don't know. Just memorize them however way you like. And then the last one is AVR, which is negative 150. Next slide. In the next slide, we'll look at where they're looking. Where are they looking at the heart? They're looking from an inferior angle. Look at the inferior leads. AVF, obviously, AVF is so obvious. We're looking at the heart from the bottom. Lead 3, you're looking at the heart also from the bottom, but at a 120-degree angle. Lead 2, same thing. So we're looking at it inferiorly. Then when it comes to the lateral leads, you have lead 1 and AVL. You can look at them from the side picture over here, like AVF is from the bottom, lead 3, lead 2 are low from the bottom. And then you could also look at the left. I don't know, my slide is stuck, so it's fine. And then the right-sided one, there's no heart, negative, no heart on the right side. So there's only one single lead to look at the heart from the right side. We don't really need it that much. But anyways, it's negative 150 degrees. So this one you can put it aside for the AVR. Okay, I want to ask you guys a question. Now we looked at the heart inferiorly. We looked at it laterally from here. We looked at it from the right. Which area did we not look at the heart? We looked at it vertically, like vertical, right? From the bottom, from the sides. What's left? Which angle do we need? Not angle, but which side? What do we need to look at it? We looked at it from the right, and we looked at it from the left. We looked at it from the bottom. What's left? There's no back. It could be, it's almost, you're close. Not posterior, we're gonna look at it anteriorly. Perfect, yeah, there's anterior. We're gonna look at it anteriorly. So from here, those red lines. So we looked at it vertically right now, but right now we wanna look at it horizontally. Do you see this horizontal circle? Horizontally inside, into the paper. Like you're adding something into the paper, so it's horizontally, these ones. Let's discuss them in the next slide. We're almost done. This is the very last thing, guys. If you're tired, don't worry, we're almost done. The very last thing is the precordial chest leads. I won't read the slide. I'll just discuss it in the picture because visual learning is the best learning ever. Next slide. You just look, 2 things you're going to memorize here. 4th intercostal space and 5th intercostal space. Which ones are in the 4th? 1, V1, and V2. But V1 is on the right side of the sternum and V2 would be on the left side of the sternum. This is simple, straightforward, 4th ventricle, خلصنا. Okay, V4 now, we'll ignore V3 for now. V4 will be on the 5th intercostal space, mid-clavicular line, in the middle of the clavicle, okay? And then you will add V3. After you add V4, you add V3 in between 2 and 4. And then this part is so easy. 4, 5, and 6. V4, 5, and 6 make a straight line. Okay, they're all in the 5th intercostal space. V4, we placed it on the mid-clavicular line. V6, we'll place it mid-axillary line, so it's inside, it's under his armpits. And then V5 is in between V6 and V4. That's all. This is the placement. Next slide. And to our luck, we're very lucky because in these leads, you don't need any angles. You're just looking at it from anteriorly. You don't need to memorize angles, thank God. So V1, okay, remember that the heart is a little tilted. So V1 and V2, let's start with V3 and V4. The placement of V3 and V4 is more to the middle. So to the anterior parts, middle of the heart, like right here. So it's anterior. These are the anterior leads, okay? They look at the heart anteriorly, straight through the page. V1 and V2 will look at the septum and the left ventricle, could look at the left ventricle, but it's mostly the septum. And then the last ones will look at it laterally because we look at the heart laterally a lot, by a lot of leads. And we finished, guys. That is it. The next slide, I've just added this really beautiful picture. I love it because it's a nice color-coded sequence for you to remember which lead looks at which side, the lateral side or the inferior side. Oh, and I have one last question before I leave you guys. Which lead should we use to get the most specific description of the heart? the very last question. We're gonna use, which lead are we gonna use to look at the most specific description of the heart? No, why should we use two? Guys, remember the elephant? Didn't we use all of the different sides? We want to look at every single angle, so we will use all of them. We use all of them to get the best description of the heart. Hopefully you guys understood this part. Thank you very much for listening, and I hope you had fun, and our friend Reem is going to complete with you guys.
حضورنا الكرام، اللي حاب ياخذ شهادة الله يعافيكم يسجل في الرابط اللي حطيته في الشات بوكس. شكرا لكم.
السلام عليكم، معكم ريم القبلان، سنة ثالث طب. راح أتكلم عن ال ECG paper، الريت والرhythm. راح إن شاء الله أحاول قد ما أقدر أبسط وأسهل عليكم، بس أحتاج منكم تتفاعلون معي وتشاركون. أوكي، أول شيء معلش next slide. أوكي، الحين راح أتكلم عن ال ECG paper وال ECG complex. أوكي next slide. Okay. وش هو ال ECG paper؟ ECG paper is a grid of small and large squares. يعني هي شبكة من ال small و large squares where time is measured along the horizontal axis. يعني في ال horizontal axis راح نعرف منها time. Each small square is 1 millimeter in length and represents 0.04 seconds. The small square 0.04 seconds. Each large square is 5 millimeter in length and represents 0.2 seconds. On the vertical axis, الحين خلصنا من the horizontal axis. The vertical axis is the electrical activity amplified and recorded for analysis. يعني من the vertical axis راح نعرف the electrical activity. Each small square is 1 millimeter in length and represents 0.1 millivolt. Each large square is 5 millimeter in length and represents 0.5 millivolt. إن شاء الله راح تبين في الصورة أوضح، بس الحين راح أتكلم عن الأهمية of the ECG. معلش next slide. أوكي. إيش أهمية ال ECG؟ ليش إحنا لازم نعرف كيف نقرأ ال ECG؟ It's important to know the rate and rhythm of the heart by the ECG paper and physical orientation of heart. Examples the axis إن شاء الله بكرة زميلتي أفنان راح تشرحها. وكمان it's important diagnostic tool for various heart conditions like hypertrophies, ischemia, infarction, arrhythmia, conduction problems, pacemaker activity. إذا صار في أي مشكلة أو خلل شفناه في ال ECG complex على ال ECG paper نعرف من خلاله أن في مشكلة في الهارت، سواء ischemia, infarction واللي هو. أوكي next slide. أوكي طيب، هذه ال ECG paper كذا شكلها. إيش إحنا قاعدين نشوف؟ قاعد نشوف مربعات كبيرة داخلها مربعات صغيرة. طيب، المربع الكبير هذا باخذه وبكبره. طيب، وبشوف معلش next slide. أوكي هذا المربع الكبير. أوكي هذا معلش. طيب، المربع الكبير هذا داخله فيه مربعات صغيرة. طيب، في الهوريزونتال axis راح نعرف قلنا التايم. أوكي time where the vertical axis represents the amplification of the activity of the heart. Okay, of the electrical activity. Okay. طيب، الحين المربع الصغير هذا قلنا أنه time صح؟ طيب، كم مدته؟ نعرف منها كم المدة؟ 0.04 seconds. Okay. While a large box is 0.2 seconds، لأنه كم في عندنا بوكس صغير في البوكس الكبير هذا؟ 1 2 3 4 5 صح. Okay. So 5 0.4 multiplied by 5 equals 0.2 okay seconds. طيب وقلنا في ال vertical axis نعرف ال amplification of the electrical activity. طيب ال small box هذا نعرف إنه صار في 0.1 millivolt amplification okay while إذا بنشوف 5 من ال small boxes هذه كم راح يعطينا؟ إذا ال small box 0.1 millivolt ال 5 boxes 0.5 millivolt half millivolt أوكي. طيب ليش يعني إيش أهميتها؟ كيف نعرف؟ يعني إذا مثلا صار في activity كذا for example خلينا نقول sorry كذا خلينا نمسح. طيب خلينا نقول مثلا صار ال QRS complex. طيب أعرف إن ال QRS complex هذه صارت مدتها 2 boxes والطول حقها إن for example خلينا نوصلها إلى هنا نقول 1 box okay 1 large box or 5 small boxes okay next slide. اوكي طيب زي ما قلنا هذه نفس الكلام اللي قبل شوي شرحته horizontally ال small boxes 0.04 second while a large box 0.2 second. vertically the amplification تكون المربع الصغير 0.1 millivolt while المربع الكبير half millivolt اوكي. طيب أتمنى إنه واضح يا رب. أوكي next slide. طيب هذه زي نفس ما قلنا أن قلنا أن هذا المربع الصغير represents كم 0.2 second صح؟ طيب كم أحتاج من بوكس صغير عشان يعطيني 1 second؟ 0.2 multiplied by 5 equals 1 second أوكي. يعني أحتاج 5 big boxes أو large boxes راح يعطيني 1 second. حلو. طيب عادة ال ECG strips تكون غالبا يعني تكون 6 seconds 6 second strip أو 10 second strip وإن شاء الله بنشوفها في الريت لما نجي نحسب الريت إن شاء الله. أوكي الحين راح أتكلم عن ال ECG complex. أوكي الحين عندنا أول شيء ال P wave. طيب ال P wave هذه represents ال depolarization of the atria. أوكي عندنا الاتريا صار فيها depolarization يعني نعرف منها إنه صار في contraction في الهارت. أوكي طيب بعدين ال PR interval هذا represents the AV node delay. أوكي زي ما شرحتها قبل شوي حنان. أوكي يعني نعرف من ال PR interval إنه صار الحين في delay of the AV node صار في conduction حق AV node. طيب ال QRS complex represents ال depolarization of the ventricle يعني إذا صار في contraction في الهارت في ال ventricle sorry راح يطلع لنا هذا ال QRS complex. أوكي طيب الحين عندنا ال ST segment. ال ST segment is beginning of the ventricle depolarization. أوكي يعني نعرف من خلالها إن الحين راح يبدأ الهارت الفنتريكل سوري تسوي repolarization. طيب بس متى repolarization راح تصير؟ في T wave. نعرف أن T wave represents the repolarization of the heart of the ventricle sorry. أوكي طيب معلش next slide مها. أوكي طيب هذا نفس الكلام اللي قلته قبل شوي إن ال ECG complex comprised of P wave. وقلنا ال P wave represents مين يعرف؟ مين شارك؟ إذا شفنا ال P wave نعرف من خلالها ال atrial depolarization. أوكي شكرا. أوكي نعرف إنه صار في atrial depolarization the P wave occurs when the SA node creates an action potential that depolarizes the heart, the atria, sorry. طيب يعني SA node تعطينا action potential ويصير في depolarization of the atria ويطلع لنا ال P wave. أوكي، فاحفظوا إنها إيش؟ depolarization of the atria, depolarization. طيب الحين ال PR interval represents وشو؟ ال AV conduction, AV node and the bundle of his conduction. أوكي، زي ما نشوف في الصورة هنا نعرف من خلالها إنه صار في توصيل للconduction المين للventricles، لأنه بعدها راح يجينا ال QRS complex. زي ما نعرف ال QRS complex قلنا the contraction أو depolarization of the ventricles. طيب ال PR interval لازم يكون between 0.12 second 0.12 إلى 0.2 seconds، يعني تقريبا 3 to 5 small squares. إذا كان أكثر من كذا أو أقل من كذا نعرف إن في مشكلة. أوكي، في مشكلة في ال AV node والبندل اوف هيس. أوكي، next slide. أوكي، الحين ال QRS complex representing the depolarization زي ما قلنا depolarization of the ventricles. يعني إذا شفنا ال QRS نعرف إيش إنه صار في contraction of the heart. طيب Q wave is any negative deflection of the beginning of the QRS. يعني ال Q negative deflection while the R is positive deflection and comes after the R, the S wave, which is negative deflection. Okay. طيب the QRS complex should be less than 0.12 seconds, which is 3 small boxes. لازم يكون أقل من 3 small squares. Okay. إذا كان أكثر من 3 أو خلينا نقول 4 أو 5 يعني في مشكلة في ال ventricles. يعني مثلا هنا خلينا نقول هذه 2 small squares فهذه normal. أوكي، بس أهم شيء ما يكون more than 3 squares. أوكي، يا رب إنه واضح. أوكي، next slide. أوكي، the ST segment. The ST segment between the end of the S wave and the start of the T wave. Okay, the ST segment should be isoelectric. يعني الحين هذه الرسمة هنقول ال QRS and T. طيب الحين هذه قلنا ال S وهذه ال T. أوكي، طيب هذه هي ال ST segment. يقول لكم the ST segment should be isoelectric. That is the same level as the part between the T wave and the next P wave. الحين في عندنا ال T wave هذه بعدها راح يجينا ال P wave الثانية. لازم تكون isoelectric مع ال TP segment. أوكي، إذا صارت مرتفعة أو كذا نعرف إن في مشكلة في القلب. معليش، في مشكلة في الهارت، وإن شاء الله بكرة راح تشرحها أفنان. بس احفظوا هذه البوينت. أوكي، the T wave قلنا ال T wave قبل شوي اللي رسمتها represents إيش؟ the repolarization مو depolarization repolarization of the ventricles. أوكي، صار في relaxation of the ventricles. نشوف ال T wave. طيب عندي سؤال. الحين شفنا ال complexes بس ما شفنا ال repolarization of the atria. في أحد يعرف ليش؟ ما حد يعرف؟ طيب صح ريناد، صح. It's masked by the QRS complex. Okay, QRS wave, sorry. طيب نجي للnext slide. أوكي، هذا الجدول نفس الكلام اللي قلته بس مرة حلو، يوضح ويبسط اللي قلناه. زي ما نشوف هنا ال P wave هنا represents وشو؟ ال atrial depolarization. طيب ال PR segment represents the delay of the AV node or the conduction of the AV node. Okay, the QRS complex represents the ventricular depolarization. T wave زي ما نشوف الريبولاريزيشن قبل شوي حكينا عنها، والايزو الكتريك لاين اللي قلنا قبل شوي ST segment should be isoelectric مع TP wave، معناته أن there is no electrical activity. أوكي طيب الحين نشوف هذه الصورة، معليش عليها. أوكي الصورة هذه كمان توضح بشكل أبسط وأسهل ال P wave يعني means إن في عندنا atrial depolarization، ال QRS ventricular depolarization، the ventricular repolarization. The T wave means the ventricular repolarization. Okay, next slide. Okay. طيب الحين راح أتكلم عن رحيم. رحيم هذه النمونك أحتاجكم تحطونها في بالكم حرف حرف، يعني لما تجون تحللون ال ECG ال ECG عشان إن شاء الله يصير أبسط وأسهل عليكم. طيب إيش هو رحيم؟ أول R يعني نشوف الريت، طيب بعدين الآر الثانية الريذم، بعدين نشوف الأكسس، then نشوف الهايبرتروفي إذا في هايبرتروفي ولا لا، then the ischemia, injury, infarction، miscellaneous. أوكي رحيم. طيب أوكي الحين أنا راح أبدأ راح أتكلم عن أول اثنين ريت وريذم، وإن شاء الله بكرة أثنين زميلتي راح تتكلم عن الباقي. أوكي راح نبدأ الحين بالريت. أوكي rate is the first thing that should be examined in the ECG complex, in the ECG sorry. نطلع الريت. وش الريت is calculated as cycles per minute. طيب كم في cycle في الدقيقة الواحدة؟ طيب النورمال هارت ريت كم تعرفون؟ كم مفروض يكون؟ أوكي ممتاز 60 to 100 beats per minute. هذا النورمال. إذا كان أقل مشكلة، وإذا كان أكثر مشكلة. إذا كان أقل يعني في براديكارديا، إذا مور راح يصير في عندنا تاكيكارديا. طيب أوكي next slide. أوكي الحين how to determine the heart rate. عندنا 4 ways. عندنا ال conventional method of 300 150 100 و rule of 300 و 1500 method، وآخر شيء عندنا 6 second strip. راح نمشي على واحدة فيهم. الحين أحتاج أنكم تشاركون تفاعلون معي إن شاء الله. ومرة حلو صدق اللي يحب، بالذات اللي يحب الماث. طيب أوكي ال conventional method of 300 150 and 100. وش هذه الطريقة؟ يقول لكم إنه 1 second زي ما وريتكم قبل شوي نحتاج منها 5 boxes صح؟ أحتاج كذا 5 sorry إيه أحتاج 5 large boxes. أوكي عشان هذه راح تعطينا 1 second. طيب 1 minute، ال 1 minute كم فيها second؟ 60 seconds. so كم أحتاج عشان كم أحتاج من box عشان يطلع لي في ال 1 minute؟ أضرب 5 boxes هذه في 60 راح يطلع لي 300. أوكي 300. طيب ممتاز. طيب أوكي الحين خلينا نقول مثلا عندنا هذا البوكس وهذا البوكس. طيب عندنا الآر الأولى شفناها عند هذا البوكس، والآر الثانية هنا. طيب خلنا يعني مثال هذا. طيب إذا شفنا الآر الأولى الآر الثانية سوري عند the second box راح نحسبها على هذه الطريقة. طيب قول 1 2. طيب نعرف إنها كم صارت 150. أوكي إذا شفنا على طول الآر بعد only one box نقول 300. إذا شفناها بعد إذا شفنا الآر بعد one box نقول 300 beats per minute. إذا شفنا الآر الثانية بعد 2 boxes نقول 150 beats per minute. إذا شفنا الآر الثانية بعد 3 boxes نعرف إنها الريت is 100 beats per minute وسو on. طيب next slide معه. أوكي طيب الحين هذا الجدول نفس الكلام اللي قبل شوي قلته، بس حلو مرة يعني بسط ويسهل عليكم. نشوف إذا شفنا only one box الآر بعد one box نقول إن الريت 300. إذا شفنا بعد 2 boxes نقول 150. شفناها بعد 3 boxes نقول 100 so on. أوكي طيب أوكي طيب الحين إيه زي هنا مثلا خلينا نقول مثلا الآر الثانية هنا طيب 300 نقول الريت 300. إذا شفناها هنا نقول the rate is 150. إذا شفناها هنا نقول 100. شفناها بعد 4 boxes 75. شفناها بعد 5 boxes 60. بعد 6 boxes نقول إنها 50 beats per minute. حلو أوكي next slide. أوكي الحين هذه بالصورة الأولى يعني هذا مثال. نشوف هنا الآر الأولى أوكي وهنا الآر الثانية أوكي. طيب راح نحسبها كيف؟ نقول 300 150 100. خلاص نعرف إن الريت is 100 beats per minute. طيب الحين على الصورة الثانية نقول 300 150 100 75 60. نعرف إن الريت is 60 beats per minute. هاي تحفظونها. طيب أو من البوكس اللي قبل شوي وريتكم إياه مرة حلو يحفظ. أوكي next slide. أوكي هذه بعد صورة نفس الشيء توضح زي ما قلت لكم الحين هذا في الECG خلينا نقول كذا. طيب الأول طيب نشوف الآر الأولى هنا بعدها only one box جت الآر الثانية. نعرف إن الريت كم 300. حلو خلاص يعني هذه تاكيكارديا أكيد مرة. أوكي طيب الحين اللي بعده نقول إن أوكي طيب أوكي الحين مين يعرف مين يقدر يحسب لي هذه؟ أوكي ممتاز 300 150 100 ممتاز شكرا. طيب اللي بعدها ممتاز كلكم 100. طيب الحين نحسب هذه. طيب نشوف الآر الأولى والآر الثانية. يلا مين يحسبها؟ أوكي صح 4 boxes 75. ممتاز يعطيكم العافية. next ممتاز 75 4 boxes. أوكي الحين rule of 300. أوكي الحين جينا الطريقة الثانية اللي هي rule of 300. هذه الطريقة أنا أشوفها يعني أسهل طريقة بس هذه works only في regular rhythm. أوكي طيب كيف الطريقة هذه؟ divide 300 by the number of boxes قصدي by the number of big boxes. ركزوا لي على أنها تكون big boxes between two consecutive R waves. أوكي نشوف الآر الأولى. طيب نشوف الآر الأولى بعدين نشوف الآر الثانية. نعد كم بوكس؟ خلينا نقول مثلا هنا 3 boxes. طيب نعد 3 boxes فأقوم أسوي إيش 300 تقسيم 3. ممتاز 100. شكرا يعطيكم العافية. next slide. بس زي ما قلنا أنا only works مع ال normal أو regular rhythm. أوكي طيب الحين هذه كيف نحسبها؟ نقول نعد كم في box between ال two R ways. طيب هنا مثلا مو واضحة مرة ال R في أي box. طيب فإيش أسوي؟ أسهل على نفسي أخذ أوضح ثنتين هنا وهنا. طيب بعد كم في box 1 2 3 4. أوكي فإيش أسوي؟ أقوم أقسم 300 over 4 كم راح يطلع لي؟ 75. حلو طيب next slide. أوكي طيب هذه بس يعني حطيتها عشان بس بوضح إنه عادي ممكن أحيانا ما تكون مثلا 2 whole boxes أو 2 whole large boxes. ممكن تكون only 1 box وهاف لأنه قاعدة أناظر أحاول أشوف بكل البوكسز ما لقيت 2 large boxes. أوكي فعادي أقسم 300 على 100 على 100 سوري على 1.5 راح يطلع لي الريت 200 beats per minute. أوكي طيب next slide. أوكي يلا مين يحسب لي هذه؟ نشوف أوضح أو اللي موجود هنا 2R waves ونعد كم في box. أوكي ممتاز. 1 2 3 4 5 6 فنقسم 300 by 6 equals 50. ممتاز شكرا شكرا لكم. أوكي ممتاز. أوكي next slide. أوكي الحين هذه يلا calculated. إيش قلنا؟ نسهل على نفسنا ندور أوضح 2R waves. أوضح 2R waves. أوكي صح ممتاز يعطيكم العافية. ممتاز صح. 300 by 2 equals 150. أوكي الحين خلصنا من rule of 300. نجي عند 1500 method. تقريبا نفس اللي قبل شوي بس بدل ما نحسب large boxes نحسب smallest squares. أوكي small boxes. أوكي If ECG machine run by speed of 25 millimeter per second in 60 seconds it will cover راح تغطي لنا 1500 smallest squares. أوكي إذا بتشوفها في 60 seconds. أوكي طيب 60 نضربها بدل مو إحنا قبل شوي قلنا ضربناها by 5 وطلع لنا 300. الحين راح نضربها by 25 عشان smallest squares راح يطلع لنا 1500. So هذه الطريقة نفس الشيء بس نحسب smallest square. How to calculate بهذه الطريقة؟ يقول لكم count the smallest square between 2R waves then ناخذ 1500 ونقسم عليها عدد small squares اللي طلع لنا. أوكي 1500 over number of small squares وبكذا يكون أنه this will be the heart rate. أوكي next slide. أوكي طيب الحين هذه محطين لنا بهذه الصورة واضحة. السمول سكويرز اللي في الصورة الأولى 10. أوكي لو عديناها 1 2 3 4 5 6 7 8 9 10. so إيش أسوي؟ أخذ 1500 أقسمها على 10. أوكي راح يطلع لي 150 beats per minute. طيب والصورة الثانية راح نعدها 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 small squares. فأروح أقسم 1500 على 15 راح يطلع لي 100 beats per minute. أوكي واضحة؟ إن شاء الله واضحة. طيب next slide. أوكي يلا الحين أحتاج أحد يساعدني. طيب نعد خلينا نقول هنا واحد 2 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. أوكي طيب خلينا نقول 1500 تقسيم 20 75 تقريبا. أوكي أو حول 75. أوكي 21 boxes. أوكي ممتاز شكرا لكم. طيب next slide please. صح يعطيك العافية 72. أوكي الحين نجي على الطريقة الأخيرة اللي هي 6 second step method. in case of arrhythmia يعني هذه أنسب طريقة نطلع فيها نحسب فيها الريت 6 second step. أوكي في حالات الأريثميا heart rate should be calculated by the step method. أوكي كيف نحسبها؟ count the number of complete cycle R to R. طيب الحين بدل ما أحسب مو زي قبل شوي أحسب السكويرز، لا أحسب كم في سايكل كاملة. دقيقة إيه هذه R وهذه R خلينا نقول هذه R هذه R. طيب كم في سايكل كاملة؟ هذه 1 cycle هذه 2 cycle cycles هذه 3. طيب أحسب كم في cycle in the 6 second step and calculate it for 1 minute. كيف أحسبها في 1 minute؟ 6 seconds multiplied by 10 equals 60 seconds صح؟ طيب ليش؟ لأنه إحنا عندنا 6 second 6 second strip زي ما وريتكم قبل شوي في الصورة. so أضربها في 10 عشان يعطيني 60 seconds اللي هي 1 minute. لازم أحسبها في 1 minute. أوكي لازم أحسب كم في سايكل في 1 minute عشان يطلع لي الريت. فإيش أسوي الحين؟ السايكلز اللي قبل شوي عديتها خلينا نقول 3 أضربها في 10 راح يطلع لي الريت. for example راح يطلع 300 بس طبعا ما راح يصير 3 راح يصير في أكثر. طيب راح يصير مثلا خلينا نقول عندنا 6 cycles فأقول 6 multiplied by 10 equals 60 beats per minute. طيب نشوف في الصورة أوضح إن شاء الله. أوكي الحين هذه ال ECG عندنا نشوف ال R wave الأولى ثانية ثالثة رابعة خامسة. طيب كم في سايكل كاملة؟ هذه 1 سايكل، هذه 2 cycles، هذه 3، هذه 4. فإيش أسوي الحين؟ أضرب ال 4 by 10 راح يطلع لي 40 beats per minute. هذه الطريقة سهلة مرة يعني نقدر نحسب فيها الريت في حالات الأريثميا. إذا مثلا كان عندنا هذه طويلة وهذه قصيرة فجأة وهذه راح نجي للرhythm إن شاء الله. أوكي next slide. يلا مين يحسب لي كم في cycles هنا؟ طيب إيش قلنا نسوي؟ هذه 1 cycle 2 cycles عندنا 2 cycles فأضربها في 10. ممتاز 20 beats per minute يعني. أوكي ممتاز. طيب الحين الثانية هذه 1 cycle 2 3 4 so 4 multiplied by 10 equals 40. ممتاز شكرا يعطيكم العافية. طيب آخر واحد 1 2 3 4 5 ممتاز 50 يعطيكم العافية شكرا. أوكي next slide. أوكي الحين بس بوضح إنه ممكن ما يكون 6 second strip، ممكن ترى الستريب تكون strip of 10 seconds. فإيش أسوي؟ بدل ما أضرب ب10 أضرب ب6 أعكس. أوكي هذه مرة طويلة معليش. خلينا نشوف كم في سايكل. هذه 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21. صار عندنا 21 cycles. فأضربها بدل ما أضربها ب10 أضربها ب6 راح يطلع لي 126 beats per minute. بس حطيتها توضيح إنه ممكن هي الميثود اسمها 6 second strip method، بس ممكن يعطينا بدال 6 second strip يعطينا 10 second strip. فبس أعكس بدل ما أضرب ب10 أضرب ب6. يا رب إنه واضح. أوكي next. الحين خلص أنا كيف نحسب الريت. راح الفور ويز إن شاء الله إنهم كانوا واضحين. راح أتكلم الحين على الرhythm. أوكي أوكي طيب كيف نحسب الرhythm؟ أو لازم أشوف المسافة between كل R و R. أوكي يقول لكم look at the RR distance using the caliper or marking on a pen or paper. عادي ممكن تحطون كذا تسهلون على نفسكم أو حتى عادي بالنظر ممكن راح نبين. إذا شفنا المسافة بين ال R و R تقريبا كلهم نفس الشيء فهذه الرhythm normal أو regular نقول. طيب يقول لكم is it regular؟ طيب are they equidistant apart؟ يعني هل هم كلهم متساويين تقريبا؟ or إذا كان واحدة مثلا خلينا نقول كذا مثلا for example واحدة الار ويف كذا مسافتها بعدين فجأة الار ويف الثانية قصيرة بعدين واحدة طويلة. طيب هذه نعرف إن الريت is irregular ونعرف إن فيها arrhythmia. أوكي next slide. أوكي طيب arrhythmia وش هو الأريثميا؟ يقول لكم the term arrhythmia can be defined as disturbance in the rhythmic contraction of atria and ventricles due to disorder. إيش المشاكل في الأريثميا؟ يعني يكون في مشكلة في الإمبلس برودكشن، يعني ما في البرودكشن حقت الإمبلسز فيها مشكلة، أو توصيلها الكوندكشن فيها مشكلة، فراح يطلع لنا أريثميا. راح يصير في عندنا أريثميا في الهارت. طيب أوكي خلاص الحين خلصنا عن الرhythm simple وما في شيء. next slide. أوكي راح أتكلم الحين على disturbances of SA node. طيب إحنا عندنا SA node AV node وفي عندنا الأتريا وفي عندنا الventricles، كل واحدة فيهم ممكن تصير فيها مشكلة وتبين في ECG. أنا راح أتكلم عن الأول يعني هذه المشكلة الأولى حقت الSA node، وإن شاء الله بكرة فنان راح تكمل. طيب disturbances of SA node إيش ممكن تصير في مشاكل؟ يا إنها تكون too slow ويصير في عندنا sinus bradycardia، أو too fast. إذا صارت too fast راح يصير في عندنا tachycardia. أوكي طيب بس ممكن يقول لكم التاكيكارديا may be an appropriate response to stress. عادي شخص مثلا متوتر معصب كذا راح يصير في عنده تاكيكارديا. أوكي next slide yes. أوكي الحين راح نسوي الريذم أناليسيس. إن شاء الله أحتاجكم بس small ones right. أوكي ما أدري سؤال لي. طيب الحين كيف راح نسوي الريذم أناليسيس؟ عندنا 5 steps. طيب نمشي عليها one by one. طيب أنا راح أسوي أول واحد وإن شاء الله أبيكم تساعدوني في الباقي. طيب الستep الأولى calculate the rate. أول شيء نحسب الريت، then determine the regularity، يعني أشوف الرhythm هل هو regular ولا irregular، then assess the P waves هل هي موجودة normal looking ولا لا، then determine the PR interval. إحنا شفنا قبل شوي كم النورمال، قلنا أنها تقريبا من 3 to 5 boxes إذا كانت أقل مشكلة، إذا كانت أكثر مشكلة. طيب the last step is determine the QRS duration، يعني زي ما قلنا تقريبا أقل من 3 boxes، إذا كانت أكثر يعني في مشكلة. طيب معليش next slide. أوكي الحين نطبق على الأولى. طيب نحسب الريت، قلنا نشوف أوضح 2 hours، خلينا نقول هذه وهذه. طيب عندنا 1 2 3 4 so بأي طريقة عادي اللي أبيها. أنا مثلا أقول الطريقة حقت 300 رول، فإيش أسوي؟ أقول 300 over ممتاز شكرا 75 ساعدتوني. أوكي طيب الحين أشوف الرhythm. طيب regular ممتاز المسافة بين كل R و R تقريبا the same so it's regular. أوكي الحين اللي نشوف ال P wave، هل في قبل كل QRS في P wave؟ نشوف هنا P wave normal ممتاز. طيب هل هي normal looking؟ normal looking الحمد لله ممتاز، كل شيء ماشي كويس إلى الآن. طيب الحين ال PR interval، نحسب ال PR interval نشوف كم في box between ال P وال R. طيب نقول 1 2 3 4 5 boxes. is it normal؟ normal ممتاز. طيب ال QRS نشوف ال QRS تقريبا 1 2 3 boxes. yes ممتاز so it's normal موجودة ونورمال، والduration حقها أقل من 3 أو أقل so it's normal. معليش next slide. أوكي so اللي قبل شوي شفناه هذه normal sinus rhythm. وش اليونيك في normal sinus rhythm؟ يقول لكم the sinus rhythm normal is the only rhythm for which all the 5 steps are within normal limits. كل ال5 خطوات اللي قبل شوي شفناها بتكون normal. إذا صار في عندنا مشكلة في واحدة منهم ما يعتبر إنها normal sinus rhythm. طيب next slide. أوكي يلا الحين أبيكم تساعدوني. طيب أوكي نشوف الحين نحسب الريت، خلينا نقول كذا. طيب كم عد 1 2 3 4 5 6 7 boxes 7 boxes. أوكي ريت كم؟ نقول 300 over 7 equals تقريبا 43 42 كذا. طيب أوكي يعني إيش؟ قلنا كم النورمال ريت between كم وكم؟ ممتاز 60 to 100. سو هذه إيش عندنا؟ ممتاز شكرا. طيب الحين الرذم، هل الرذم نورمال؟ نشوف المسافة بين كل واحدة. المسافة is it normal؟ نورمال رذم ممتاز شكرا. البي ويف نحسب البي ويف 1 2 3 4 احنا قلنا ان الريجولر between 3 to 5 so it's normal. طيب سوري هذه قبل شوي حسبتها بي ار انترفال. طيب البي ويف هل هي قبل كل كيو ار اس موجودة؟ هذا الكيو ار اس اي ممتاز، قبل كل كيو ار اس نشوف فيها البي ويف واتس نورمال لوكينج سو اتس نورمال. الكيو ار اس كومبلكس نشوف تقريبا 1 to 2 boxes. هل هو نورمال؟ 2 boxes. احنا قلنا اهم شيء ما يكون اكثر من 3 so it's normal. yeah ممتاز شكرا. طيب next slide. اوكي so ايش المشكلة بس اللي شفناها اللي قبل شوي؟ عندنا bradycardia. طيب ايش اليونيك about sinus bradycardia؟ for sinus bradycardia the heart rate is less than 60 وزي ما شفنا قبل شوي كانت أقل 42 تقريبا and all other measurements are within normal limits. الباقي شفناها حسبناها وكل شيء كان normal بس كانت مشكلة في ال heart rate إنها كانت less than 60. okay next. يلا الحين أبيكم بعد تساعدوني لو سمحتوا. طيب أحس كثرت عليكم شوي ها. طيب خلينا نشوف هنا، خلينا ناخذ أوضح ثنتين for example هذه أوكي هذه الآر وهذه الآر. طيب إيش قلنا؟ أو خلينا نجرب الconventional method الحين. 300 كم؟ 100 150 ممتاز. أوكي 150 so 150 هل هو normal ولا لا؟ يعني هل هو between النورمالات؟ no. إيش عندنا؟ tachycardia ممتاز. طيب الحين الرذم نشوف الرذم هل هو نورمال؟ تقريبا المسافة بين كل واحد ثاني is it normal؟ is it regular؟ نقول الرذم regular ولا irregular؟ ممتاز regular yes ممتاز. طيب الحين البي ويفز هل في موجودة البي ويف قبل كل كيو ار اس؟ موجودة. اوكي normal looking. اوكي البي ار interval نحسبها تقريبا 1 2 3 4 so it's normal. اوكي والكيو ار اس تقريبا 2 to 3 small boxes so it's normal. اوكي طيب next please. اوكي اللي قبل شوي شفناها sinus tachycardia. sinus tachycardia حسبناها تقريبا 150. طيب وش اليونيك about sinus tachycardia؟ يقولون the heart rate is greater than 100 وزي ما شفنا قبل شوي 150 and all other measurements are within normal limits. اوكي الحين آخر واحدة هذه. طيب نشوف أول شيء قبل لا نحسب الريت هل إحنا قاعدين يعني نشوف إنها normal أو الرhythm regular. شوفوا هذه المسافة هذه المسافة أصغر هذه المسافة أصغر هذه أصغر هذه طويلة no so it's irregular rhythm. وإيش قلنا الطريقة الأفضل لحساب الأريثميا؟ يلا مين يقدر يساعدني؟ 6 second step ممتاز. 6 second step هي الطريقة الأفضل. طيب كيف نحسبها؟ يلا مين يحسب لي إياها؟ ممتاز. قلنا نشوف by cycles. هذه 1 cycle second cycle 2 3 4 5 6 7 نضربها ب10 ممتاز شكرا ناد. طيب so 7 by 10 okay equals 70 beats per minute. وقلنا irregular rhythm، المشكلة هنا irregular. طيب والبي ويف هل هي موجودة قبل كل QRS؟ موجودة صح؟ موجودة. طيب البي ار انترفل نحسبها. اوكي نشوفها 1 2 3 4 تقريبا it's normal yes. والكيو ار اس تقريبا 2 boxes which is normal. اوكي اوكي next one. اوكي هذه sinus arrhythmia. Sinus arrhythmia is a condition in which the heart rate remains within normal limits. الهارت ريت عادي احنا قبل حسبناها كم؟ تقريبا 70. Is it within the normal limit؟ قلنا ان ال normal limit كم؟ 60 to 100. 70 between 60 to 100. So يقول لكم ال heart rate is within the normal limits but influenced by respiratory cycle. هنا المشكلة هنا normal ترى، بس إنه influenced by the respiratory cycles and variations of the vagal tone causing rhythm to be irregular شوي. يعني عادي هي normal بس مع التنفس وكذا يتغير على إنه يصير في عندنا irregular rhythm. طيب مع الانسبيريشن خلينا نقول الواحد لما يتنفس يصير عندنا increase في الvagal tone. وقلنا لما إحنا نعرف إذا صار في increase في الvagal tone الهارت ريت راح يقل معنا. طيب لأنه إيش يسوي لنا الفيجل تون؟ راح يقلل لنا الهارت ريت. أوكي مع الإكسبيريشن راح يصير في عندنا decrease في الفيجل تون وعكسها طبعا راح يصير في الهارت ريت والإنكريز. فعشان كذا راح نشوف الرhythm كذا واحد عادي واحد طويل بس إنها within normal limits زي ما شفنا الريت within normal limits. أوكي next slide. أوكي وش اليونيك about the sinus dysarrhythmia؟ the PP أو زي ما إحنا نحسب قبل شوي ال RR intervals will progressively widen the narrow. يعني مرة نشوفها بعيدة بعضها نشوفها لا قريبة. following the patient's breathing pattern عادي هو بس قاعد يتنفس وقاعد يتغير شوي بس إن عندنا الريت is normal. so هذه sinus arrhythmia. وأنا خلصت ويا رب أن يعني قد ما أقدر أني أكون بسطت عليكم سهلتها. بس إذا عندكم أي سؤال تقدرون تسألوني هنا يعني في الشات عادي موجودة أنا. يعطيكم العافية. شكرا لحسن استماعكم. شكرا. الله يوفقكم. الله يعطيكم العافية يا رب. اللي عنده سؤال ممكن يسأل عادي في بالشات أو اللي تبون.
ريم في سؤال بالشات.
أوكي إيه ساينس أريثميا اللي قبل شوي شفناها إنها نورمال، بس مع التنفس زي ما قلنا. ليش؟ لأنه إحنا نعرف الحين حسبنا الريت وطلع الريت نورمال، so it's normal، بس مع زي ما قلنا التنفس. يا رب وضح.
طيب ريم، في سؤال: what is the normal PR interval؟
النورمال PR interval زي ما قلنا between تقريبا 3 to 5 small squares، اللي هو لو نحسبها في small squares تحت قلنا horizontally 0.04 sorry 0.12 to 0.2. أكتبها أحسن، 0.12 to 0.2 هذا النورمال، تقريبا 3 to 5 squares small squares. يا رب وضحت. يعني إذا كانت أكثر من 5 small squares في عندنا مشكلة، أو إذا أقل في مشكلة.
طيب إذا ما عندكم أسئلة، شكرا لكم جميعا على حضوركم، وأنا بحط رابط للي حاب ياخذ شهادة يعبي اسمه بالرابط التالي. شكرا لكم على حضوركم.
Do both ventricles contract at the same time? شفت سؤال في الشات. إيه بينون التو ventricles في نفس الوقت في QRS complex the two ventricles والاتر كمان نفس الشيء.